Carly, ready?
Hi, my name is Jennifer Wren.
I'm Connor Drobel.
My name is Mitchell Bennick.
And our business is called Quickline, which we believe is going to reinvent the public transportation system. So have you ever been waiting for the bus, and you're just sitting there wondering where it is, and then when it actually shows up, you can't take the bus anymore because it's already full? Or on the other hand, have you seen that empty Pace bus going through your neighborhood, and isn't that a little bit wasteful? And this can't be good for the environment either. Why do we need to send a bigger bus than we already need to? And obviously, traffic is also an issue which public transportation can address. However, it's not where it could be. So this is where Quickline comes in. With the rise of the number of smartphones being used and internet use, we believe that it would be an effective input for people to actually be able to put in their own information to redesign the bus system. And for people who don't have access to internet or don't have smartphones, we want to put a $35 tablet, it's already developed from India, on each bus region. So people can go on the site and then enter in their own data. So essentially, this is how our business is going to run. First, riders can input their data on phones, the on-site tablet, or on their computers. Then that data is inputted into an algorithm, and that algorithm then generates a new bus route, which also determines the size of the necessary bus and to make it more efficient.
So essentially what riders see is an HTML or PHP interface where you can basically enter in your information. This is kind of a rude concept, the more developed one, but you'll see later. And so basically it gets input into a MySQL database, which...
We take the data from the MySQL database and we basically use Dijkstra's algorithm and some graph theory in order to optimize for, first of all, like distance that the bus has to travel between picking people up, and basically it dynamically alters the route after every single input of individual data. So, like you'll see later some of the algorithm working.
So like we said before, the main idea behind Quickline is to make the bus system more dynamic. So as you can see here, this is what the bus system is currently at. It's a rigid system, it's a rigid schedule where people have to follow what bus companies have already determined. But why can't we optimize that? Depending on the number of people and where those people are who want to ride at a specific time, then we can take their data and then reconstruct the bus route. And also, as we said before, if we have only 10 people on the bus, then we don't need to send a giant bus to pick those people up. And again, we also want to send them back real-time updates so they know exactly where they need to be and what time, so we don't have to see people waiting at the bus stops for half an hour again. And so with this idea, where do we stand with our competition? That's really hard to say because we really don't have any. As you can see here, this is where major bus companies are right now. They're very rigid, and comparatively, they're taking more fuel than they need to. Carnegie Mellon has actually designed an app called Tiramisu, which sends their users time where their bus is and how full the bus is. But the difference between Quickline and Tiramisu is that Tiramisu is a feedback program. So basically, the information that's already there is sent to the users. But Quickline takes information from the users and then puts it in to reconstruct the bus route.
And so the concept is actually already going. We have a working prototype with a working Android application, which I can demonstrate in front of you if this video loads. And so basically what you're going to see, if it loads, please load. So basically what you're going to see is you're going to see the Android desktop, and it's actually a working app. You can go download it if you'd like, although it's not really going to go anywhere. This is the Android SDK, by the way, which it was developed in. And so you see the Quickline app right there with the cool little logo. And so you're brought to this interface. You select what day it is, because you maybe want to book in advance. You select your time and your bus stops. We're just doing concepting out, so it's pretty just simple right now. And then when you're going to hit submit, eventually, hopefully. So for example, I want to take a bus, and I know I'm taking a bus tomorrow at 10 p.m., and maybe I think I'll forget, so I'm going to do this ahead of time. So I'll press confirm, And so I'm brought to an interface that ensures that I'm entering in the proper information, because God forbid we have a bunch of people entering in the wrong information all the time, and we have buses going in circles. And so after that, you confirm the information. You can also return back to the previous page if need be to correct the information. You will give a confirmation notice, and it can even send an email. And the other powerful tool, feature that I just developed is that if you know you're taking the same bus every morning, you can save it, and so it'll keep booking the same bus every single morning. So if this is something you're going to do every day, you don't need to think about it, it'll just do it.
Now on the algorithm part, it receives the data from the SQL database, and it evaluates the current routes to check whether or not the bus is already going to go to the stop and drop the person off. If not, it looks at possible routes using Dijkstra's algorithm. It comes up with 3 different possible outputs, and then decides on which bus to use to go to which stop based on which of those 3 outputs leaves the maximum amount of people on each bus and limits the total amount of distance traveled by the total buses.
The other powerful part of this app is that if you know, for example, that there's a squeeze point in traffic, you can essentially ban you can ban certain routes in the program, and that way, if you know like there's a route with a bunch of stop signs, you can avoid those routes because they're really unnecessary. Otherwise, it's extremely dynamic and do it on the fly.
And so obviously the benefits extend beyond the riders. So the companies are able to save gas if they don't have to send a giant bus when they don't need to. And obviously this benefits us as riders. We don't need to always drive and pay for gas, and also benefits Mother Nature. And so how exactly are we going to make money from this? We've considered creating an app where we can sell ad-free apps or just have income from those advertisements. But the main source of income is charging a % of how much those companies actually save. So taking the example from how much fuel is consumed, at over $4 a gallon, companies are spending over $2 billion on just fuel. So if our algorithm is able to save their companies 1/3 of how much gas they have to save, and we charge 10% of that, we already make $60 million annually.
And so essentially what we need is investments for implementation. So the nice part is that bus stop comes out to be about $500 with an on-site tablet, a solar panel, and a battery to keep it to charge just in case like you have a stormy day. And so the really nice part is it's completely off the grid. You don't need to rip up ground to put in lines, it's all wireless. A digital wireless infrastructure, which would cost about $5,000 for an area like the city of Aurora. Servers to handle requests, with $2,500 you can get virtual private hosting, which would be more than enough to handle all the requests and everything else we need to do. And maybe some extra money for unexpected complications.
And so obviously this is our market size. Right now there aren't very specific numbers on exactly how many passengers there are, but that's exactly what our app can do. Using that information, we can also determine more specific and fill that information deficit. And we can also use this system and implement it into different markets. So these are the future possibilities of Quickline.
For example, if you need like a solid one, if any of you stayed at a resort and you need to travel around the resort, say Disney resort, and you always have to wait on that shuttle, why should you really have to wait on that shuttle? If you know you're going to be out the door in half an hour, hop on your smartphone, you go on the Disney tourism app, and you say, I need a shuttle at my door in half an hour, and sure enough, half an hour later, you're going to go out your door, and the shuttle's going to be nicely waiting for you.
So thank you. We should take some questions.
Is this going to be like a large group taxi cab where they just travel all over the place?
It's actually going to have a set route that it follows when no users have implemented any data. So if people were to continue if there were people that didn't have access to the internet and the bus would already have would be able to stop by the route, or if people weren't willing to get an app for their phone or something along those lines.
So are you operating the buses, or are you expecting like the CTA to adopt the system?
So essentially what Quickline is that we've created a new system. And so this system is written in, So it's written in Java, and so it's easily implemented into what the bus companies already have.
And so basically the second half of this would be an app basically for a tablet with GPS enabled. And so basically the information would get dumped to a bus driver. So the bus driver would have this tablet and it basically tell them where their next stop would be, and in case there needs to be alternate routes that are created, it can basically run the route by itself without really the bus driver doesn't really need to know where they are because the GPS can handle all of it. That's the only end that really hasn't been developed, but it could also just real stream, and so as long as the bus driver knows the area, that it's really not required. We already have all the existing technologies made to implement this.
So we're not creating a new bus company, we're just changing how they're run right now.
So have you talked to the CTA about that?
Actually, the CTA is trying to implement a system right now similar to the Carnegie Mellon University system, where they take data. But what we really want to do is we want to take big data, or they collect data. What we really want to do is we want to take data from the consumers and generate stuff around that.
Yes.
Just to validate your case, I think you are on the right track. I just came back from Barcelona yesterday, and at Mobile World Congress, people were given an app so they could locate taxis on demand, and the taxi drivers would know where traffic was so that they could route, their cabs accordingly. So I think this is on the right track, definitely.
And going back to a previous question, the other powerful thing about this is, especially with the Android tablets and for the bus drivers, we could essentially use the GPS features of those to track the buses, and so at the bus stops you could see a live stream of exactly where the bus is. So if you're kind of wondering, well, how much time do I have until the bus gets here? You can see on obviously part of the app, okay, so I know this bus is here and this bus is here. I know which one is coming to me. So if I want to take 5 minutes and grab McDonald's really quick, I know if I have that 5 minutes to spare because I want to show up to work, obviously, wherever you want to go.
Thank you very much.